Hello and welcome to the inaugural episode of View Dependent, the podcast that brings you the latest news, reviews, and perspectives on neural radiance fields, otherwise known as NeRFs. My name is Michael Rubloff, and I'm joined by my co-host Jonathan Stevens. On today's episode, we'll be going through the latest NeRF news, such as Matt Tancic's move over to Luma, as well as Apple's WWDC event. The main focus of today's episode will be the paper called Neuralangelo from the NVIDIA team, which you may have heard a little bit about. There's been a ton of speculation about how this is going to affect both the NeRF and photogrammetry community, but we'll dive into all of that and more on today's episode. So, whether you're a seasoned NeRF herder or you're just getting started, there's going to be something in this podcast for you. Please enjoy the episode. All right, well, so let's go ahead and get started then. There's been a lot of news this week. First up, the biggest thing I think to come out of the NeRF world is Matt Tancic is going over to Luma. Matt is also known as the co-founder of NeRF Studio and several other NeRF papers, including the original NeRF paper itself.
Can we redo this, by the way?
Yeah.
One thing. Can you hear my kids? They're reading loud outside my door. I would think we should actually probably introduce me as well, because you're going to monologue, and then we're not going to jump in and, like, I'm assumed, like, let's have some banter. Say, hey, Jonathan, you're like, because this is our first episode, so we should probably introduce ourselves as well, or whatever. Right. Hey, Jonathan, hey, yeah, okay. So you can take a crack at that.
Sure.
This is messy. This is the fun part of the first episode.
Yeah, no, it'll be a lot of edits, but it'll turn out well.
Yeah, cool. We'll just dump all of this, by the way.
Yeah, no one will ever see us, hopefully. Anyways. So my co-host.
Yeah, so be like, hey, welcome, Jonathan. Welcome to the show. Yeah. I'm excited. This is our first show. Let's get this started. Let's be, people who don't know us, let's give them a quick bio. Okay.
Right.
Yeah. Bring a lot of energy. I want some clipping on the audio.
Yeah. So this is episode number 1 for us, and I'm extremely excited to have my co-host Jonathan Stevens here, who is the chief evangelist over at Every Point, to talk all things about NeRFs. And we're excited to be able to actually get going to tell you all about NeRFs. And yeah,
really excited, Michael. Like I said, I'm chief evangelist at Every Point, but I've been really just keeping my eye on the ball on NeRFs. And you yourself has started Neural Radiance Fields.io, the website. And so I think there's just a lot to talk about, and there's no podcast. There's not much content. In general, me and you have made a huge impact in the world of NeRFs, just because the lack of content, lack of understanding. So that's what we're here to do. Break down news, talk about topics, interview people. Really exciting.
Yeah.
So thanks for getting this together.
Of course.
Yeah, what's that?
Yeah. So Jonathan, actually, I originally reached out to Jonathan a little bit over a year ago, maybe like a year and 4 months or so. And at the time, it was really just Jonathan that was putting out content about NeRFs. And for me, coming into the space, I truly knew nothing. And for me, it was like a quest of, how do I get Jonathan Stevens' attention to actually help me build out NeRFs? And since then, the field has really exploded, and that leads us to today, where now we're finally being able to help pass along some of what we've learned to anyone who will listen.
Yeah, definitely. When I started out, it was pure curiosity for our team as a computer vision company, making sure this isn't new technology that's going to just eradicate or just replace everything we're working on. And so, and I started making tutorial content that NVIDIA picked up and the world picked up. So, we're just here to educate and, give us your each viewpoint on what we think NeRFs are going. Because I say, Michael, you got a lot different background and look. I come from a very technical background. I think about commercial use and industrial use, and you think more creative space. So we have two different viewpoints here. So I'm excited about that. Let's jump into the news. What do you think?
Yeah, let's go for it. So there's been actually quite a lot of news just even within the last 24 hours. The biggest thing that's gone on is Luma AI, one of the leading NeRF platforms specifically for iOS, has hired Matt Tancic. And for those who don't know who Matt Tancic is, there's maybe two or three other people that could claim to be a deeper expert in the worlds of neural radiance fields than Matt. He is an author of the original NeRF paper, as well as a co-founder for NeRF Studio, and is also a co-author of papers such as Instruct NeRF to NeRF, Language Embedded Radiance Fields, and pretty much you would be hard-pressed to go within more than 3 paragraphs of any Nerf paper without seeing his name being cited somewhere. So it's a huge hire for Luma, and I'm excited to see what Matt is able to contribute to their team.
Yeah, definitely. There's a very few names that come up when you think of the original group of scientists in this field. He's definitely one of them. Probably has one of the deepest knowledges when it comes to this. I actually had interviewed him on a podcast, and he explained NeRFs in such a elegant way that hopefully most anyone would be able to pick that up. And I think he'll be a huge asset for them. What one crazy thing is there's not a lot of places to land for a NeRF researcher nowadays. So if you want to work for a large company like Google, Apple, obviously I'm sure they're hiring people who are doing NeRF research. But if you don't want to work in that big, large corporate situation, Luma AI is it, and it's exciting to see them grow as they've gotten the latest funding. So I do wonder, like, what that means. Are they just going to be? Is he going to work on improving Luma's quality of output? Something? Does he got new tricks in the bag we have yet to see? It'll be interesting.
Yeah, you're right. And it's also going to be interesting too to see what happens to Nerf Studio. As I mentioned, he's one of the co-founders of the platform, and from what I've been able to see so far, it doesn't seem like he's going to be 100% with Luma. It seems like there's still going to be some development of Nerf Studio continuing on. When I was going through the Nerf Studio Discord quite a bit, kind of going through this thread where Matt actually can be found pretty often responding to any troubleshooting or anything really that you want to reach out to him about. And he was still saying, Nerf Studio is going to continue. So I'm very curious to see how the two continue down the road in terms of Luma and Nerf Studio, but both serve amazing purposes within the Nerf community, and you definitely hope to see Nerf Studio continue on.
Well, this doesn't surprise me either that we continue, because it is a community project. If you think about it, that's an open source continuum of code being committed. It's not just Matt or the original 3-4 people who worked on it. Now that is really grown, and so I don't think he needs to be like one of the sole people committing code to that project to see it flourish. But yeah, I do wonder if he'll be definitely not as engaged in the GitHub portion of it, responding, what that is. But also, I've talked to recently I talked to the creator of OpenMVG. That's for multi-view geometry. And he has a project, an open source project that he did a decade ago. He started, and he's still actively doing that at the same time, working for one of the largest spatial computing companies. And it's not like, hey, when he got hired, you have to stop that. In fact, to him, it was like his way to work on things outside of what he can't talk about. Because I'm sure whatever at Luma AI they're working on, he can't talk about publicly until it's out there. But there's something else unrelated, but also in this, you got the outlet of being able to talk about what he's working on in that other part of the research. So it'll be exciting. That was big news. Not surprising, at the same time surprising. So
yeah, I mean, they have the Avengers of the Nerf team now. I mean, they have Matt, they have Alex Yu, and Matt's advisor, Professor Andrew Kanazawa as well. So it's been pretty impressive to see the team that they've assembled thus far, and it's pretty awesome to see everyone going towards the mission of essentially, I think what they say is democratizing, access to 3D content. And I was actually following a thread yesterday by Amit Jain, who is the CEO of Luma, talking about how he views photos versus 3D content, and really being able to push everything forwards into a 3D environment, which is something that always resonated with me for Nerf, is just how do we take where the current state of photography is and push it forward into a more ubiquitous format of 3D content. So I'm very, very excited to see what the Luma team is going to be doing.
Yeah, that's how Amit says he's trying to make 3D easy. So well, I want to touch on that topic further down in the news, but let's jump to our next news item that we had lined up here. NeRF, memory efficient radiance fields. That code is available. Again, that might have been a news. That actually, when that came out, NeRF might have been something that you totally missed if you were paying attention to what's happening in NeRFs. But basically, it was a paper that was published that made, I was able to look at now a pre-trained NeRF on a mobile device, or like a non-high-end device, and get really, really good fidelity and not need that high-end GPU. But the code is not available. So, yeah, Michael, now you get to play with it.
Yeah, no, I've been looking forward to being able to kind of get in there and explore with Murph. We've seen, and the interesting thing about, the Murph paper itself is that it is a partnership with Google. And we have seen Google start to venture a little bit more into the world of NeRFs over the last few months. You have the immersive view within Google Maps, and then pretty quietly, I would say relatively, they announced product NeRFs for specifically with the vertical within shoes, I believe. And so now that Murph is available, I'm kind of curious to see, does Google start to expand the verticals at which NeRFs are going to appear within product search? Or does that just mean that shoes become even more popular all of a sudden now that this code base is available? I'm kind of curious to see what the follow-up from this new code is going to be.
Yeah. And one thing I did notice, because I did go to the GitHub page to see what the code implementation looks like, and it's built on Jack. So again, that might be over a lot of people's heads. Just know it's like optimized to work on Linux, so a lot of people might not play with it right now. But there's if you spend some time, you can figure it out how to get your own data in there. You can run Jacks on a Windows machine if you know what you're doing. I'll be excited because I'm tired of having to be the only way to really look at a NeRF in real time is to have an NVIDIA RTX 3000 plus series, and not everyone has that. So everyone just thinks NeRF's a pre-rendered video. That's because it's the only way I'm able to show it to you on the internet. But if I was able to, say, like, hey, click this link and look at a real-time NeRF on your side on a browser, I think we'll cross that gap, realizing this is actually not an offline only view, but you can have a real-time view.
Right. And I think we're headed in that direction as well with some of the other papers too. Like, for instance, one of the co-founders of Luma AI, which is a plugin native to NeRF Studio that allows you to open a file in Unreal Engine, a NeRF in Unreal Engine, just published a paper called NeRF Lite, which essentially really decreases the memory and size footprint of a NeRF file, and will hopefully kind of go hand in hand, at least I'm hoping for, in the future, to make it a little bit easier for the average mobile device to power to visualize a NeRF right on in browser.
Yeah. Well, we're heading in the right direction there. All right.
Yeah. So moving on to a couple more things in the news. You want to talk about Apple really quick, since we were just it just happened. WWDC was just a couple of days ago. Everyone was kind of wondering, are they going to say the words Neural Radiance Field? How many times will they say artificial intelligence during the actual presentation? And I think that it was zero. I think,
they weren't all talking about AI. It was machine learning. They said that, it's kind of like AI is the hot topic word to use. Almost like if you don't understand AI, you just say, oh, it's AI. But they were like, no, we use machine learning here. They use some other more technical terms, but also the audience they are talking to is developers. That is their key people they're talking to. So it makes sense that they didn't just say AI like Google would.
Right.
It's definitely present. We didn't see any NeRF technology shown, which I think it could be a good thing.
But did we see anything that was utilizing NeRF technology in the background is kind of what I'm wondering. It was very interesting to hear their messaging around spatial photos and kind of reliving these immersive memories as something that I kind of view as one of the primary use cases of NeRFs themselves. And it's been really interesting to kind of see what Apple is thinking from their new headset and going forwards, and how humans are going to interact with content. One question I had was, is the headset going to be stable enough to actually record usable footage to relive in a 3D environment, or is it going to be too shaky?
Yeah, I think it will. I think Apple doesn't put anything out there shaky or not consumer ready. It's gonna have. It's not ready yet, though. The headset's not out till next year. I'm not surprised about that, because it didn't sound like they're ready, but they're kind of being forced into it. I think whatever they're gonna put out there is gonna feel as close to magic as possible, especially at that price point. It's got to be. You can't have shaky footage at a $3,500 price point.
Yeah, no, I totally agree, and I'm looking forward to being able to put it on, try it out, see exactly what Apple has been working on for God knows how long. I think it's been a long time coming. The internet has just been ablaze, I would say, the first half of this year with the expectation of it being released. And now that, it's been out there, I'm starting my countdown clock of when I can actually get to try it myself.
Yeah. Yeah, and then I've been keeping a keen eye on just the people who have got to try it at WWDC live, and they all said, well, it lives up to the hype of what they saw, but also keep that in mind, the fact that it cost so much that it's got to be magic. You're not gonna put a thing out that's over 3 times more expensive than the Quest Pro. And not feel like you get 3x the quality or 3x the experience. So yeah, it'll be exciting. But I was also excited at WWDC. This, they're always making developments for developers for iOS and iPad OS and all those, and they are pushing just the whole entire AR kit, reality kit, being able to make 3D models much easier using embedded, the embedded APIs they have for photogrammetry, world building, things like that. And to me, that's really exciting because all that crosses over into NeRFs as well. And so I'm sure one day there'll just be like images to NeRFs, and you won't even, you don't have to deal with all this stuff that we deal with. It'll just be a magical version of it.
Right, exactly. So I'm excited to see where it goes. And yeah, 2 other quick papers just wanted to throw out there that have been in the news recently are in-paint Nerf 360 and then deceptive Nerf. And by extension, we can also talk about Nerf Buster as well, which kind of does a similar thing in mind. But we've seen a few different editable Nerf papers, such as Instruct Nerf to Nerf, also going back to Matt Tancic, as well as Nerf Shop. But where in-paint Nerf 360 really comes into being is that it's able to provide complete 360 in-painting within a Nerf itself. And from what I understand, it really utilizes depth to understand from, depending on what the view is, of what that bounding box should actually be capturing in order to make it editable, which I think is something that is pretty crazy to see. In terms of how fast everything has been progressing, and I think it's going to be a really useful tool that eventually will be paired with some of the other papers, such as LERF, to make insanely cool use cases out of it.
Yeah, I think that's something people have been waiting for. Just more options to edit, more options to fix up, touch up. I got really excited when they had the VR version of Instant NGP, just for the fact I could erase something.
Oh yeah.
Let alone in-paint something. So I see that was always kind of like the thing as Nerfs were really good for capturing a space as is, and you got what you got.
Right.
But it's kind of like, no. Well, now you can add things in, fix things you don't want in the scene, put things, over something to hide it. I like that.
Yeah. No, it's extremely exciting. And then we also have the paper Deceptive Nerf, which essentially introduced this concept called a pseudo observation. And essentially what that means is if there's a gap of data within an actual Nerf, and typically from there you'll either get just a void or you'll get a ton of artifacts. But this actually is able to sample those points of missing data and evaluate the local proximity to it, and essentially fill in a generative image that will kind of take the place of that to help fill in and give it more context. So it's pretty amazing stuff. And in terms of getting Nerfs cleaner and cleaner, I have a little bit of mixed emotions on it based upon inserting just overtly not actual data into real life environments. But I think as a whole, the technology it's kind of brilliant.
Yeah. Yeah, it was inevitably coming. All this, being able to just edit things, change things. So, it'll be interesting. I also could see just doing like these. I could just imagine for even doing like, I don't know, self-driving car training simulations, things like that. Because that's where I come from, the viewpoint of how you use industrial. And it's like, well, maybe you're removing things that shouldn't have been in the scene, so you have an ideal canvas to work off of. For perhaps, say you want to do like some warehouse simulation, it's It's like, ooh, there's a couple of things sitting out there in the Nerf that we didn't want. Well, we can take those out, but then we can also put things in.
Right.
Hey, what would it be like if this thing was in the way? And so, yeah, it's definitely going to get more helpful to have some editing tools that, just did not
Yeah.
exist about 6 months ago or
Right.
a
And
few
quickly
months
going
ago.
back to, the VR side of instant NGP, it's a very therapeutic activity actually to go into a Nerf in full VR and to start like removing the artifacts as well. It kind of feels like you're, either painting or chiseling away, which, we can maybe use as a segue into our main topic, who is named after, the sculptor and painter Michelangelo, which
Hmm.
is a new product from NVIDIA called Neuralangelo, which has kind of set the internet on fire in terms of some of the things that have been thought of, and one of the places that might be making some large changes to other existing technology.
Yeah. In fact, I'm gonna actually just add to our screen. So if you're not listening but actually watching this on YouTube stream, I got some visuals I'm gonna put up on here because I think showing is almost the best way to understand this new what do you call it? This new paper, this new technology versus just talking about it. But it just swept my social media in a single day. How about yours, Michael? Do you see anything else newsworthy come out that day? You
No,
know,
that was pretty much, dominating the Nerf news cycle for me. And, a lot of big claims were being thrown out from a lot of people around the internet. I think the main question is this death to photogrammetry on the spot?
yeah. Well, my strong feeling is no, not even close. This is not going to replace photogrammetry, but that's my viewpoint. I,
Yeah.
I think we should start out kind of like what even it is.
Hmm.
And if you look at their like abstract, they kind of call it out. They say it's a powerful, a powerful reconstruction alternative for recovering 3D surfaces via image-based neural rendering. So, like what they're saying there is, it's in the past, most of the ways you want to represent a discrete surface, discrete being like an actual wall, an object, a real thing there, and it's like got a hard surface. You could, let's say, in a game engine, pick it up. Um, you use photogrammetry. That's taking images. You figure out, okay, where's there common points between the images? Okay, those common points are surfaces. Figuring out points on the surface, and then wrapping it in some sort of mesh, and then putting some textures on it. And that's like the current way that most companies use. And then so this is saying, oh, we're going to do exactly that, but now we're going to use a neural rendering. We're going to use a neural engine. We're going to use AI. We're going to predict where that surface is. So it's just a completely different way. And to be honest, this actually isn't new technology that they have here. It's not like, we just for the first time came out with 3D reconstruction from using a neural network. That's been around for a little while. It's just this is way better than anything they've done in the past. So that's exciting. So if you read that abstract, it might go over some of your heads, but that's what they're doing. Is just think of what photogrammetry does, but with a neural network that is better than anything that's been done in the past in a neural network. So yeah, and so if I drag down here, you're gonna see that you got this, these great 3D models, and there was no photogrammetry to get that surface. And I think you can like jump around. If you were to go to the website for Neuralangelo, and we'll put those in the show notes, it shows just different scenes. Of course, they're not loading on my screen, but here's like a building, and they'll show like the old method, which is this news NEUS is like one of the older versions where just you could get a building, but it's like, think of if you ever use instant NGP and you try to get a mesh out of it, it's just kind of like really low quality. Well, that's kind of like where that was about. But Neuralangelo, it's like a ton of those details come into focus.
Yeah, exactly. And it seems like, for me, I have a Nerf Discord channel where, we try and provide any troubleshooting or just a place for people to talk about Nerfs. And when it comes to instant NGP, one of the questions we get most often is, how do I get a mesh out of instant NGP? What's the cleanest way to do this? And for a long time, like you were mentioning, it really that's not what it was intended to do at the time. But now with, I think, this innovation, we're starting to get to that point where it's becoming a reality. And we can go into it a little bit more about the timelines that are associated perhaps with when we'll see it in Instant NGP. But the way that it seems like it works, there's really two parts that power Neuralangelo. Obviously, it's building upon Instant NGP as well as SDFs as well. But there's really two different parts that they utilize. They actually use numerical gradients as opposed to analytical ones, where previously, the gradients were more functioning on a more localized level and wasn't able to really expand across a larger area. So if you had like a wall, for instance, and they demonstrate actually a few different walls and buildings in the product page, but now it's able to actually understand on a larger scale how to get a high fidelity and more like texture within it. So if you'll notice, you'll see a lot of them will show either the bricks, or some of them will have like, I don't know, like an HVAC unit or something on the side of the building that perhaps wasn't really going to be glossed over in prior methods, but now it's really able to be seen and visualized. And the other way that they have this powered essentially is through a coarse to fine method. So similar to how you have AABB going from 2 to 16, for instance, they have a similar method in that they have different levels between 2, 4, 6, 8, 16, which will introduce more and more detail.
So like think about it this way: is like at the lowest level, it makes out the shape of a building. Like, okay, there's a building there. It's kind of like a blob, but you're like, oh, that's probably that big giant bump's got to be a building. It's somewhat shaped like that. Then the next up, level is like, okay, now I can figure out roof versus walls versus some basic geometry. And then the next level is like, okay, now I'm starting to figure out like not just roof and walls, but maybe where the windows indent a little bit. But you're still not getting a lot of detail. So each time it iteratively goes through, and it keeps refining. And then so like once it's got a major wall where it's really well defined and a big flat surface, it'll keep refining just that part of the model. And in that way you can keep producing finer and finer detail in that final output. And you kind of see that with like octrees is something you see in structure from motion photogrammetry. It's kind of like taking a section and it works on it, and then it breaks that section up into 4 sections, and then it works on each 4 section, and then as you split each section in 4s, you can get more and more fine detail. And then there's parts where perhaps there's a loss function. You get less and less detail out of it. Well, it can stop getting. You can focus on getting more detail out of the more complex areas, which is kind of a neat way to speeds it up as well. And then it's also optimized to look for like losses in curve and flatness. And it's like, okay, I understand it's a wall and it's pretty darn flat, and it's just going to make it flat as opposed to trying to make it curved, things like that. It does pretty well.
It's interesting too to see the breadth of examples that they give, because on one of them it's like looks like almost like a surgical tray where they show these different like scissors and other instruments, and you can see the level of detail that they're able to actually visualize and refine. I think it's scan 37. If you go up just a little bit, it's that second one, scan 37, I think. Once it loads. But it's interesting to see like this tray here to me, and you're able to actually see the level of details. I'm not sure if that's what specific instrument it is, but you can see the ridges within the actual metal itself compared to the prior methods, and you can see how well it works on small scale. But then you also go to some of the other scans that are really large items, such as like the courthouse, for instance, and you're able to get so much more detail pulled back out of it that it's very fascinating to me that it's able to work in both cases like that. It's really not one or the other. So I'm excited to see how you can use it for various use cases.
Now, I will point out, I think this is where people still are getting confused. People are still going to understand this whole technology. Is that if they show these, if you watch the video, you see this awesome visual of this. So I'm looking on my screen again. If you're to jump in and you to the web page that we'll have in the show notes, and you go down and you look at, let's say, the Johns Hopkins University building, you've got this cool spire, and you get like the background, you see like the skyline and all that. And you're like, wow, all that's mesh. It's like, no, not actually, because what you're looking at there is still it's producing 2 outputs. You get your view synthesis, which is like a NeRF. You're getting what it's going to look like from that angle. But then you're getting a mesh, and the mesh is not textured. Those aren't linked together. It's not like you're getting a texture on top of the mesh. And so that's why, does it replace photogrammetry? Right now, no, because you still need a textured mesh. This is only optimized to get geometry, not textures. So like keep that in mind. And it does like normals and all that, mapping, all that. But till you get the textures, you're kind of like just you're getting almost the whole photogrammetry output, but minus that. But if you really know what you're doing, if you get the camera poses and you get the geometry, you can do texture mapping yourself after the fact if you want. But I think people look for an end-to-end solution for making game-ready objects for Unreal Engine or something like that. This is going to get good geometry, but you're not getting that textured mesh that we're used to using. So, Michael, that pushes me into the question: what are we using this for?
Yeah, it's a great question, and I'm not 100% sure what the answer to that question is just yet. And part of the reason why I say that is it's not disclosed actually how long it takes to train this. So while we have the finished results right in front of us, even though it's built on top of Instant NGP, I am pretty positive that it's not trainable as fast as Instant NGP and takes quite a bit longer based upon what I saw in the paper. So I'm very curious to see how long it would actually take to, because I think that's also something you'd have to take in consideration for a real world case.
Now, they did have some speed benchmarking in the supplementary, but again, I don't know how to do the math. They benchmarked it with, a crazy PC configuration, or computer configuration. So it's like, well, I don't have that. So like, what does that mean for me versus someone who's got, multiple GPUs set up, and not just regular GPUs. We're looking at the Tensor Core packed ones. So if you do, because there's no code out and you do want to play with basically the same technology to get these high quality meshes from a neural network, I do suggest you check out SDF Studio, which is basically the same technology, and it's built on Nerf Studio. So you can just, if you have Nerf Studio installed, you can go get SDF Studio, and it's basically like, think of it as like Nerf Studio. You've got these different Nerf implementations you can test out. Well, this is the same thing. You've got all these different SDF, and that's SDF is basically the process to get this geometry, and you can play with it on your own PC to like see how it works and start to learn about it as well. So that's my recommendation. There's that. You can play that. I think they're going to use this again just for, hey, I want to. It's you're starting to get these real-time renderings and game engines of these sort of environments. It's like, well, I don't care if I have a textured mesh. If I could render using Nerf and other technology, if I could render the neural network in real time, the Nerf visualization, and then have the geometry behind it as an invisible layer, I got everything I need. It's like, as long as I don't have to pick up the object and play with it, and I'm just trying to build, let's say, a world I can run around in, and then I can populate with other meshes that I create myself. Well, there we go. I can create a whole world with just a Nerf and the 3D geometry and have all the collision layers and everything. I think that's where this is going to head. We'll see what they do. I'm sure it's going to be part of the Omniverse. Like maybe I want to get a warehouse, or I don't know, a football stadium as an arena to put some sort of experience in. Well, I can just Nerf that whole darn thing using Neuralangelo, and then build some sort of game inside that. So I don't have to go, build that environment around it.
And I think where it'll also continue to go to is, I think a lot of papers or these methods will end up utilizing LERF, or language embedded radiance fields, to help power other experiential items. So the example that Matt Tancic gave in his lecture at MIT was a grocery store essentially querying their entire inventory with LERF and allowing wayfinding capabilities for customers to say what aisle are these chips in, and the computer being able to route it.
Yeah, that truly gets to your well, that's got his own can of worms that he threw out there, but that gets into your spatial computing of being able to merge like a digital and a physical. That there's a physical reality out there and there's a digital version of that out there, and if you can merge those through something like a headset, you can say those things, or even your phone, where it can guide you to it.
Right.
I say it's a big can of worms because I don't know if you've ever been to like a Lowe's or a Home Depot. They'll tell you where it's supposed to be, and maybe even last time that thing was seen, but people are picking it up and moving it all the time. So unless this Nerf is updating like all the time, products are obviously being moved all the time.
Yeah.
I just know that for a fact. But like, oh, I guess the cereal will always be where it's supposed to be. You just might show up and there might not be any left or something, or if it's a rare item, it may have gotten moved. But I do know there's a can of worms where people are always saying like, oh, well, I'll just be able to query it in a store and it'll walk me right to it. And I know it's like, well, things move a lot in the stores more than you expect. So
yeah. See, I always want, from the topic of like Lowe's and Home Depot, it is just like a Nerf method that will tell me what steps to do to actually put something together in terms of like taking a look at like what I have built so far and making sure that I don't build it wrong the first time. So I'm looking forward to
and to me also finding something is a solution. I feel like it's hard to really beat upon. Like, okay, I look up where this object is. I want to buy an impact hammer. I don't know, something like that. Impact drill. I mean, from Home Depot, and it'll say, okay, it's aisle 8, bay 37. Well, I can walk to that. I don't need a headset to get me there.
Mm-hmm.
I'm pretty sure us humans are pretty good at that. But yes, like it's when these complicated, like you said, doing something that perhaps is something more complex that doesn't have those signages and things that could be really helpful. Like, I don't know, maybe you're at an oil and gas plant, and it's like there's parts of that plant that are so complex, and someone rarely ever goes and checks these valves and gauges. Well, that won't be touched in between, so maybe it gets nerfed, and then it'll walk you to what to do once you get there and how to get there and all that. So it'll be interesting which way that goes.
Yeah. So it's going to be fascinating to see how all these different methods build on top of one another to create these new experiences for people. And I do think that while it's not by any means a photogrammetry killer yet, I think that it does at least start that pathway a bit.
Yeah. And the whole SDF field, it's implicit neural representations. It's not new. It's been moving, and just know that like it's at a point, it's getting to the point where it is, depending on how detailed you want it to be, that it is getting in real time where you're getting robots to be able to navigate off this technology and things like that. And then they talked about in this paper how you're not using. It's not guided. So like in the past, you could perhaps take like, let's say LiDAR, or you could take a point cloud using photogrammetry, structure for motion to aid them getting the 3D model. It's just saying, hey, we're even beating those that has an aid. It's like, this is unaided. This is just using pure images. And that's really exciting because then it's like you're removing all that compute time to get some supplementary data to help figure out where the surfaces are. So that's really, really exciting. I think we should I would love to do a follow-up episode where we actually talk about some of these concepts in SDF and all that. Maybe demystify it for people. Because I deal with it a lot, and I think a lot of people just like it goes over their head. Not that you really need to understand it, but it helps to know like what's, like what is SDF? What does that is in versus this classical stuff we've been doing? Why is it magic? And then also like what are the pitfalls? Why in some cases it isn't the perfect technology? So.
Yeah, we should definitely we'll add it to the episode list.
Yeah.
The one question I have, and I don't think there has been any answers or any comment on it just yet from NVIDIA, is just when will it be available? When will even if you have a supercomputer and you want to try it out and you have the actual power to do it, when can you do it? And so I don't think that it's been addressed yet. I have a feeling that once it is addressed, getting instant NGP running it was going to make a huge difference. But I'm very curious to see what the actuals would take to run it.
Yeah. And I don't have it up on my screen. I thought I did. They haven't even been updating instant NGP. So I mean, they had a tiny update today, or a couple days ago. I do wonder if they're working on some sort of huge update, like adding the whole framework to it, or, we don't know. They've been quiet, but it feels like, for a while they were pushing updates like every day. And now it's like, what's happening? Are they working on this big massive update?
Right.
I do. Here's a poster for CVPR worth a look. That's coming up at the end of the month here, end of um, June. That's a computer vision and pattern recognition conference, the premier conference in this whole technology. And they could announce the code maybe during that or after that. I don't know. It's something maybe to keep an eye on, but it
Yeah.
could be that that's what they're waiting for, because you hear it June 18th through 22nd in Vancouver,
Yeah.
BC. They
I'd be
might be
very
waiting.
curious. Yeah, we'll have to see if they demo it or not. While if you are going to CVPR, though, there is going to be a Nerf art gallery on display. I think curated by a collection of people, including John Barron over at Google. So if you're going, I highly recommend checking it out. Send photos. I will not be attending, so I'm very curious to see what it looks like. But apparently, there's over, I think, something like 2 hours worth of Nerfs that are going to be like cycling
Yeah.
through.
Yeah, I won't be there either, but I'll be in that art gallery. And what's amazing is that you submitted up to a minute for the art gallery. So if they have that much, they had a lot of submissions, which is exciting. But it's an AI art gallery. So it's anything to do. It could be other things as well besides Nerf. So it'll be interesting. I hope that they post it online as well for people who aren't attending.
Yes.
To see.
Same here. Yeah, otherwise I will have to ask someone to wait for 2 hours.
Yeah, I don't want a coworker to sit there with an iPhone and record it for 2
Yeah.
hours and then send me a recording that's shaky. So
Exactly. Yeah. So hopefully it gets published online. I'm really looking forward to seeing all the other papers that come out in advance of that. There've been more than I could possibly keep up with thus far, and we're still a few weeks away. So it's been amazing to see all of the new technology coming out, Nerf related and otherwise. So I've been really excited to see how everything's been progressing.
yeah, and if you're really curious, because CVPR is where a lot of this big announcement stuff is coming from. If you do go to the CVPR website, if you just type in CVPR 2000 or 23, there is in the news, they have a list of accepted papers and awarded candidates, and it's a gigantic list. I mean, like thousands of papers get accepted every year, but they now have a version where you can go look at the list is a Google Drive, sorry, not Google Drive, a Google Sheet. And then you can just type in the word like neural and just start scrubbing through it, and you'll start to find the papers in there. And you also have a link to the PDF page for a lot of them. So you could just go then see the name of the paper and go put it in to Google, and you can usually find it. But it's fun to see, what's out there. I found some gems that are solving a very small problem for neural networks or for computer vision community in general that are just like like the underwater one. Like most people aren't taking Nerfs underwater, but sure enough, someone is. And in fact, I know someone personally who makes underwater camera systems, and he got really excited when I sent him that, and he's like, "Oh my goodness," because doing underwater Nerfs is just not very. This doesn't work very well because of all the scattering of the light and all the sediment, things like that. Just becomes like a cloudy mess. And you say, well, if I can remove that. Very helpful.
See-through Nerf blows my mind that someone has figured that out. And I have a friend who's currently in Hawaii right now, who's actually very active in the Nerf community. It's James Perlman of Turbo Nerf. And hopefully we'll get some underwater Nerfs coming back from that trip, or we'll have to see. But there are a ton of papers that have just been amazing to really understand.
Yeah, definitely. All right. Well, I think that wraps up our first episode. Hopefully people like it. I love feedback. People send us comments at the end of this. Lots of news. It's like I blink and there's always 5 or 6 new things, and that's part of the magic of being close to CVPR. Everyone's putting out new papers, but I'll be excited to see the stuff that gets out of the paper phase, gets into the code phase where we can play with it.
Yeah, but I think now we're getting towards the portion of papers that were announced earlier in the year, such as Murph, that are now having their codes actually be released ahead of CVPR. So I'm curious to see what some of the other papers that announced earlier this year start to make it into real world applications. And but like you said, this is our first episode. There's clearly a lot to build on, and let us know what you guys think. any feedback that you guys have for us is immensely appreciated. And yeah, hopefully you guys enjoyed it. Hopefully this wasn't a drag to. Hopefully you are sitting through it. So.
Yeah. If you're watching this on YouTube, leave a comment and let us know, like, hey, how did it go? If you want to add, we talked about news. We try to talk about like a big news item. We plan to interview some people. But yeah, let us know what you think, how you'd like to see, what you found most valuable. Because I love feedback and these sort of things because we make them for ourselves, but we're also, want to make sure it's valuable for everyone else listening in.
Definitely.
All right. With that, how about you read us out, Michael?
Well, that wraps up our very first episode of View Dependent. We hope you enjoyed the deep dive into Neuralangelo and the roundup of the latest news. NeRFs are consistently evolving, and we want to evolve right there with it. We're committed to bringing you the most up-to-date and engaging content possible, but in order to do that, we'll need your help. So, if you enjoyed the show, please consider subscribing on your favorite podcast platform so you won't miss our next episode. And if you have a minute, we'd really appreciate if you could leave us any reviews and or feedback. Your feedback is immensely valuable to us, and this was our first show, so I'm sure there's a lot. So please feel free to reach out and let us know what you think so far. We also want to hear in case you have any comments or questions about today's topics. Do you have a different take on Neuralangelo? Or maybe you have some other insights about Matt Tancic's move over to Luma? Or perhaps you have some predictions about how Apple might use NeRFs going forward. Whatever it is, we want to hear from you. You've been listening to View Dependent. We can't wait to take this journey with you.